friends and hello student. My name is Ashok Sijala. In this session, we learn the binary number to convert in the decimal number in C language. So let us, and that is a conversation, I think, in CFET in your subject. Okay. So here, yes, number conversion, that topic is, so here we can binary number, you have to know 0, 1, and that convert to in decimal number. So yes, here turbo C++ is there and that's selected. So that process, yes, and now is open and Alt F file menu taking new file, and here our definition of program, write a program to enter binary, can say that binary, yes, yes, binary number to decimal number. Okay, so binary to decimal conversion is there. So we can also say that write a program to convert binary number to decimal number. So here I use the convert binary number to decimal number. So yes, for technique in every session, input and what is a process and then what is a output. So here convert to binary number to decimal number. So we can enter the binary number and display the decimal number. So that is input output is a fix, and convert, that is our process logic. So you have to, I think, know very well. So how to convert, like in we can enter, I give the idea, I think here paperwork. So like 1, 0, 0 and 0. So that is a 8 of our decimal number. So here we can first to define to every 0, like here we can define like of 2 here I above or below, what is here, because there is no difference, because here 2 rest upon, okay, so 2, that is our divide 2 every, and upon 2, 0, 1 and 2, and multiplication operation is there. So here how to do? So first we can take, like I separate this 0, so here and here and here, yes, then multiplication operation. So 2 raised to upon, yes, that is a main important of this session. Upon we have to some number is there. So we can use the power function then and then that possible. So we can 0, yes. So first we can define the in reverse order. Yes, you have to know very well. So 2 raised to first we can define the 0. Yes, so I write this type of, because we have to not upon in this in turbo. So that is a upon sign, yes, that, and that we have to first 0, and then upon sign, yes, and then 1, yes, and then upon sign, yes, and then 2, and then upon sign, yes, and then 3. So here first 0 raised to, but that multiplication is 0, so all are 0, you have to know very well. 0 multiplication, all are 0, so here answer is 0, and here also 0, because that is multiplication 0. Here is also 0, but here is a 1, so 2 raised to 3, so 2 multiply 2 multiply 2, so 2 multiply 4, 4 multiply 8, so here come to 8, 8 multiply 1, so 8 is there, so that answer is 8. So that is a example, we can say that, consider. So that type logic we have to apply conversion. Okay, so now let us start how it's work. So just Conio, and then for standard input output. So anyone above or below, that is no problem. First you can take the standard input output, or then first. So here we can give that main function our next section, and we can define, yes, our logic. So that is a, like we can first take our number, and here that binary number is so long, so here we can take the long integer, otherwise taking garbage value. Yes, and then we can take decimal number, so and that assign to yes 0, otherwise that create some garbage value. And then I, that counter, yes, that we have to take. And then reminder, rem, reminder. Yes, let us check clear screen. Yes, and then we can first enter, that is our input. So enter uh, decimal number. Yes, so we can scan to our n variable. Yes, percentage d and then ampersand n. Yes, and you have to know very well, in our number programming we can take here not how many iteration to our loop iteration, how many times, that known as iteration. So we have to not judgment in initial stage, so we cannot take for loop, but while loop is always. So n is not equal to just 0 or greater than, we can also check here. First not equal to condition we have to use. And then reminder means that you have to know, we can divide our first divide by modulo 10, so separate digit, because that is a decimal binary number, so we can store in reminder value. And then n means that our new and divide operation, so equal to 10. So what is a full form of this statement? N equal to n divided by 10. So that is a short compound assignment. Division and equal to compound means assignment operator. So you can use any arithmetic or all most of operator, but arithmetic is more using compound assignment operator. Then decimal to our number, and then also I take short technique, plus equal to, and reminder and multiplication. Yes, reminder, that is our digit binary separate module operator, and then we can take in reminder. And that is what we can do in paperwork, means board work. So power function, so 2 and rest to 2 rest to I, because we can start 0. Yes, so 2 rest to I we can initialize 0, and then I plus plus. So our goal is perfectly, first I is 0, then plus plus 1. So 2 rest to and multiply that digit, we have to divide, multiply and store in decimal. So what is a full form of this statement? Decimal equal to decimal, DEC equal to, and reminder, so means our separate rem means reminder that value. Or you can say that digit, d for digit also, because that binary number, but here we can rem use, so you can also use d for digit. And then what is a full form? That multiplication and power function. So that is a full form of, for right, for your reference. So here 2 time, yes, here is a plus sign. Yes, so here one statement, then decimal DEC and DEC 2 time use one variable. So here we can plus or equal to, that is short technique. And here we can also use short technique. Here we cannot use, because here the reminder and n is totally different. One statement 2 times same variable use, that time you can use the compound assignment operator. So that is short technique. Okay, so after our while loop is complete, our number is ready and can print. And the we can say that enter not yes, here some message is not perfect. We can enter the binary number. Yes, so my previous program is a, so binary number and decimal number print, that is a perfect. So now enter binary number and print our decimal. Here is a decimal number, so here I give decimal number is, okay, first we can input the, and that also percentage LD, yes, and then DEC print. And also in scanning time we cannot that LD, yes, so long integer we have, because the binary number is so long is there. So yes, let us check get ch, and first I save this file. Yes, so what is giving the name? So binary, yes, and to decimal DEC.c. So binary to decimal number conversion. Okay, so yes, compile, yes, any error, yes, one is there. Okay, so here is a power function use, so that giving the error because power we have to take header file, and semicolon is already we have to put, and comment line. So yes, here is semicolon. So here giving the error, but here is semicolon is required. Okay, and let us now is perfectly clear. And here we also taking power max library. Otherwise, sometime taking error. So max.h here not any error, but anytime appears, so we can apply to alert. Okay, now we can same our 110. Yes, let us that is a binary and provide the decimal. So perfectly our program is completed. Let us check some other number. So here 1011. So what happened? Yes, 11 is there. So decimal to binary. Yes. Now we can take some different number like you have to know very well. 001. So 1 is there. Yes. Now you can say 0101. So that is a 5. Yes. So that is very simple. Yes. And let us check other number. So 0011. So that is 3. Yes, so I think perfectly, yes, that program is perfectly work, I think. Okay, so and let us check here, but not equal to 0, we have to take condition. So ultimately our is also possibility you can provide the not equal to 0, greater than or less than or equal to. Yes, after our number is, let us check first. I take the while watch, and then we can check also conditions. So different, so not equal to here I use. Okay, so I think all are well, and let us check watch window. So our for perfectly work or not. First I close this message window that is not required. Yes, and then alter W and taking here watch and outputs. First watch, and then we can also take the output. Yes, so there is only two line, means output in enter any binary number and take input as a decimal number. So here our variable first n that number, and you can also decimal, but we can print the decimal DEC number. And then I, that is very important, that is our upon 2 raised to upon I. And then we can take these decimal number, and first we can take reminder, yes, and decimal number. So here change also that any watch you can set, and then if you require to change that variable, just enter and remove this variable and again give to your required variable. So here I change, yes, and now yes, all are complete. Let us check that our define the 4 variables, all are there, and decimal I and reminder. So I press F7. Yes, you have to know very well here alter R, and here trace into F7 shortcut key. So compiler starting always main or function compilation. So F7, yes, all are, let us long integer is there. So many big number garbage value, that known as garbage value. Now decimal and I initialize 0 here, look, and other two garbage. So we can assign I equal to 0 and decimal, because n is scan and reminder we can separate to here. So that's our binary number. So yes, enter binary number. Yes, that message is appearing, and then press F7. Yes, I give our paperwork 8 number. So let us how it's work. Yes, and not equal to 0. So yes, condition is true, means that false, but that is true, not equal to true or false, false equal to true. Inverter like in circuit design in CFET. So that type of not equal. Yes, and then yes, press F7, that enter. Yes, and our reminder that is a separate to uh, 0 digit. Yes, reminder is 0, and then new number is a 1000. Yes, that is a divide. So 10, so that is a 100. Yes, 100 value is remaining. Yes, and here reminder multiply power 2 2 upon I is 0 initially. Yes, I is 0. So that is a only 1 is there. Yes, and multiply remainder is 0, so all are 0, and decimal is already 0, so 0 is 0, yes, no any here decimal is 0, and then I plus plus, so I is now 1, yes, and then again not equal to, yes, condition is true, means that is false but true. Okay, so here that modulo operator separate again 0, yes, and new number is 10 only, yes, here is 10 because divide 10, and then again remainder is a 0, multiply power 2 raised to I is 1, so that is 2 raised to upon 1, so 2, but the 0 is there, so decimal is there again 0, no any change. I plus plus, yes, that 2, yes, now 2, condition is not false, true or false, false, so that enter, and 10 modulo 10 means that is only 0, yes, so that remainder is 0 again because there are 3 0, and then new number is only 1, yes, that 10 divided by division, so only 1 is there, and then again 0, all are decimal 0, now you have to know very well, and I plus plus, so I is 3, now that is a calculate, yes, that is last, and then remainder is 1, yes, that remainder is 1, now is a, yes, now 2 raised to 2 raised to 3, 3 and multiply here 1, so 2 multiply 2 multiply 2, so 8, 8 multiply 1, so that is 8, yes, decimal number 8 is, and I plus plus, but our loop is here false, while loop false, because not equal to 0 but equal to, so that is a false, yes, and then print, yes, so very simple, we have to define to our logic. So here that number is a 0, that time we can out of the loop, and also, yes, let's check if we greater than 0, that type, that ultimately that is a 0. So but binary number is there, so you can enter the 0 0, that time problem creation, yes, so binary number is there 0 1, so we can always give not equal to, yes, so I give the, so that is what is the important of this while loop, not equal to 0 in our number programming, what to do here, greater than 0, n is greater than 0, okay, not equal to, but we can also here not equal to means not equal to 0, greater than equal to not appear in this condition. So yes, I again run, yes, so we can trace also, so here I give different like 1 1 1, yes, and then 0 0, so that is so long, that value, and that is all are 0, okay, because that is so long number. So here, yes, let us check again, because that is a creation, some we can give the not, yes, so that is a 6, yes, so that is a long integer, so range is not problem, otherwise you can what happen here also, you can take the long integer, that is also possible, yes, let us check how it's work. So here I give long and long, that is a long, so here 2 LD, yes, that is I think first time to your, yes, let us check whether that work or not. I compile first save F2 and then compile. Yes, there is no any error. So let us check. So now you can give any long is long, that double range is there. So here we can 0 1 0 1 0 0. So 8, because you have to know very well. So yes, now is a 8 is there. So yes, 36 answer is there. So you can calculate. So here that possibility long to long integer, yes, here we cannot provide integer, so long to long, and double LLD, that is formatting symbol LLD, and here also LLD decimal number, that not required, but here we can all variable, you can also, our binary number is a long and other also you can take in simple long or integer, that possibility not required, because I is only normal, very means normal range, remainder is only 1, and decimal is average, so here two part you have to divide, like here we can give like other over normal, that integer variable, and here n is only required, so we can, yes, let us check. So I here only d decimal number, because decimal number is not out of range in our integer, yes, so there is no any error, and let us check again testing this what happened. So we can give like our so first 40, and then we can take some. Yes, let us check. So that is a yes, buffer is overflow. Power function sometime not getting perfectly because all are 0, 0, 0, 0. So that taking because here multiplication, yes, here is a we can take multiplication and then sum is there. So remainder is a not taking integer. So we can remainder is multiplication and then assign to decimal number. So here we can take uh, that our previously yes that perfectly works. So here we cannot take integer, decimal we can take, and only r I is only we can take in a integer. Let us check that I equal to 0, that is only, and let us check now again. So I give again same value 0, 0, 0, 1, 0, 1, 1. What happened now is perfectly work. So sometime that power function is overflow, so that is happen because there is a so long is range is there. Yes, so 11 is there. Now let us check again. So now I give like first 0, 3, 4, 0, that is binary, and then 0, 1. Yes, that same is it. Huh? So yes, 1, 1, 1. Yes, let us. So 7 is there. Yes. So you can directly let like a year give 0 and 1, 1, 1. So that is also 7. Okay. So you have to know very well. So both we have to input 8 first 0 4, and then we can actual number is there. So that is a complete, yes, so many testing, and we can check all the perfect that program is work. So here binary to decimal conversion. So you can conversion system to apply all logic. Okay. Now I complete this session. Yes, write this program to your note, very simple, develop the logic here. Okay. So now I close this file. Yes, and then quit means all watch output and then quit. So subscribe my channel Ashok Sijal Academy. Press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.